Alright, in this video we're going to continue on with applications of quadratic functions, and this is going to be an area problem. So it says, Emily wishes to expand the size of her front garden, which is a square. Emily measures her front yard and decides she can increase the width by 5 feet and the length by 9 feet. If the area of the newly expanded garden is 285 square feet, what were the dimensions of the old garden? I'm a picture person, so I think pictures really help. So the old garden was a square. We don't know the side length, but it's the same for each side. She decides to expand the width by 5 feet. So there's an additional 5 feet here. So that side length would be x plus 5. And she's going to expand the length by 9 feet. So now the length is going to be x plus 9, right? I guess I should have done it from down here. And we know the area. So area in general is just length times width. The area of the new garden is at 285. So we're replacing A with 285. And the new garden has these side lengths. So x plus 5 and x plus 9. So I'm going to go ahead and multiply this side out. We're going to get a quadratic, which means we're going to need to get everything on one side and try to factor. So let's do that. So you need to box or FOIL this. X times x would be x squared. Then we'd have 5 times x and 9 times x, and 5 times 9 is 45. So just distributing this to both parentheses. I'm going to combine my like terms. 5x plus 9x is 14x. And then because it's a quadratic, I need to get everything on one side, set it equal to 0. And now I'll have 45 minus 285, which will be negative 240. Now, in the last videos we did, nothing was factorable, but it still needs to be your go-to. I see something that's not linear, so x squared here, it's quadratic. I need to think factoring first. If it's not factorable, then I resort to the quadratic formula. It's true the quadratic formula will always work. It's just there's more places that things could go wrong, and factoring can be faster. So in this case, I want something that's going to multiply to negative 240 and add to a positive 14. So factors that multiply to negative 240 and add to 14. Right away, I'm seeing 24 and 10. Right? 24 times 10 would give me 240. And I have to put a negative with the 10, so it will add up to positive 14. So it is factorable. Our leading coefficient was a 1, so I go right into my parentheses of x plus 24 and x minus 10. And set each factor equal to 0 using the zero product property. That means that x could be negative 24 or positive 10. But since we are talking about side lengths, we're not going to have a negative side length. So that's not our solution. The answer must be 10, which means the original garden was a 10 by 10 foot garden. And there you go. So there's another application for you with quadratic functions.